Welcome back to infyGyan, my dear friends. In this video, we have another very interesting question from radical equations, and we have to find out all real values of x. So let's get started by writing domain of the equation. This radicand must be positive for real x. This radicand must be greater than or equal to for real x. Here I will say x plus 1 must be greater than or equal to for real solutions. So from first condition, I can write x must be greater than or equal to half. From here, x must be greater than or equal to 2 and x must be greater than or equal to -1 from here. Now we have to consider the intersection of these three conditions. So we will conclude x must be greater than or equal to 2. X cannot be less than 2. I will solve this question in two ways. So let me write here method 1. Here I will use substitution. So let us consider square root 2x minus 1 equal to a. Square root x minus 2 equal to b. So a must be positive, b must be positive. From this equation I can write a square. This will be equal to 2x minus 1. b square x minus 2. Let's subtract second equation from first one. We will get a square minus b square equal to x plus 1. And you can see our RHS radicand is x plus 1. So in this place we can write a square minus b square. So I can write equation as a plus b equal to square root of a square minus b square. Now I will consider squaring both sides. Let me write here a plus b equal to square root a square minus b square whole square. Now square root and power 2 will be over. So I can write a plus b whole square equal to a plus b times a minus b. Let us take all the terms to one side. A plus b whole square minus a plus b times a minus b equal to 0. Now a plus b is common. We can write a plus b minus a plus b equal to 0. Now plus a minus a will be over. So we can write a plus b times 2b equal to 0. Or b times a plus b equal to 0. From here we will write two equations. First one, either b equal to 0, and second equation will be a plus b equal to 0. Let us solve both the equations. First I will write a plus b equal to 0. Then we will consider b equal to 0 equation. So from this equation I can write b equal to negative a. Once a and b both are greater than or equal to 0, I am splitting in two conditions, b greater than 0, a greater than 0. So left hand side will be positive and RHS will be negative times positive. So this will generate complex solutions. So the only condition which will hold true when a equal to 0 and b equal to 0. So a was our substitution root 2x minus 1. B was our substitution root x minus 2. So I can write root 2x minus 1 equal to 0. Consider squaring both sides. 2x minus 1 equal to 0. Add 1 to both sides. 2x equal to 1. Once we will divide both sides by 2, x will be equal to half. And condition on x was x must be greater than 2. So we will reject this solution. Now the turn of b0. This was a0. Now b0. And you can see b0 is also here. So we can write b equal to 0. b is square root x minus 2 equal to 0. Consider squaring both sides. X minus 2 will be equal to 0. Add 2 to both sides. We will get x equal to 2, which is our accepted solution. We will verify through equation at last. Now method number 2. Here I will consider our equation as square root x plus 1 minus square root x minus 2 equal to square root 2x minus 1. Now I will consider squaring both sides. So power 2, square root and square will be over. Now I can write square root x plus 1 whole square plus square root x minus 2 whole square minus 2 times square root x plus 1 times x minus 2 equal to 2x minus 1. Now square root and square will be cancelled out. So I can write here x plus 1 plus x minus 2 minus 2 times square root x plus 1 times x minus 2 equal to 2x minus 1. Now x and x, this will be over with 2x, and 1 minus 2. This will give us negative 1. Let me write negative 1 minus 2 times square root x plus 1 x minus 2 equal to negative 1. So this is also cancelled out. Now I can write here square root x plus 1 times x minus 2 equal to 0. Square root x plus 1 times x minus 2 equal to 0. Now consider squaring both sides. We can cancel square root with square. We will get x plus 1 times x minus 2 equal to 0. So from here we can write x plus 1 will be equal to 0 or x minus 2 equal to 0. So from first equation I can write x equal to negative 1. But our condition on x was x must be greater than or equal to 2 for real x. So this solution we will reject. Now x minus 2 equal to 0. So x will be equal to 2. Let us check whether it is satisfying our equation or not. So I will write here verification. X equal to 2. LHS. Equation is here. So I will write square root 2 times 2 minus 1 plus square root 2 minus 2. So I can write square root 4 minus 1 plus square root 0 square root 3. Now RHS. Square root x plus 1. So 2 plus 1, which is square root 3. So LHS equal to RHS. We can conclude x equal to 2 will be our only real solution. I hope friends you will like this video. Thank you so very much for watching. Till next video. Bye bye.